let's continue. Hello, ping pong point. Welcome. Okay. So let's continue in the process homework. Okay, let me take a look. Okay, the run process this run.py, the Python script. Let me check. This one. Okay, and then I think this one, right? Okay. The following flag, test L. Let us see this one. Comma separated list of process to run. List of process to run, okay. X1, Y1, where X is the number of instructions that the program should run, okay. And Y is the change, or maybe probabilities, if I can type correctly, okay. Is the probabilities from 0 to 100 that an instruction will use the CPU or issue an input-output. Okay. If Y is 100, a process will only use CPU and no input-output. If Y is 0, process will only issue input-output. Okay. This make me curious. CPU intro, process run, I think, okay, 100, okay. Okay, because we didn't have the flag TC, this one, we are actually not running the script, this one, because we already exit in this conditional. So this is the report of what would happen when we run this process. Okay, process 1, process 0, CPU. System will switch when the current process is finished or issue an input-output. Switch the current process will switch when the current process is finished, okay, or issue an input-output. After input-output, the process issuing the input-output will run later when it is its turn. Okay, kind of curious. Okay, we have process 0 and process 1. Alright. The process issuing the input-output will run later. Can we change the, what is it called? The policy, right? Oh, I think this one. Switch on I/O. When to switch between process, switch on I/O, switch on N. Okay, process switch behavior. Okay, switch on IO or switch on N. I am still not sure what is the difference. Like switch on, what switch on IO does and switch on N does. You know, the policy, or what is it called? Yeah, the policy maybe. Okay, so we can change that. I want to try out, let's say 50. Okay, CPU. Okay, this is exactly 5, right? And this one, CPU and then IO underscore done. Okay, CPU again and then IO done. Oh, this is one process, this is the second process, the third, fourth, and fifth. Oh, okay. And we have this extra, what is it called? State, I guess. Now let's try using S. What is the default switch on IO? Okay, let's try maybe something like this. Switch on N. System will switch when the current process is finished or issue an input-output. Or issue an input-output. After the input-output, the process issuing the input-output will run later. It's done. System will switch when the current process is finished. Oh, okay. Issue an input-output. So if the current process is not finished, and then what happened when the process issue an input-output? Oh, okay, wait a minute. So when the current process issue an input-output, we will switch to another process. So like, what is it called? The state become, where is it? The state become block, right? And then we're running another process. But in this case, I assume that we need to finish the current process. So this will keep being ready, I assume, until we are finished running the previous process. Maybe this is just a hypothesis for now. How long the input-output takes? Okay. The process list, okay. More specific control over programs. What is program in here means? Oh, okay. is the control we can add with this flag, the test P flag. And then this is the input output done. Output ends. Okay, the default is run later, but we can also change that to run immediate. Run immediate. Okay. Alright. Let's try this flag. Test I run immediate, something like this maybe. Okay, after the input outputs, the process issuing the input output will run immediately. Wait a minute, what should we analyze from this homework? Okay, what should the CPU utilization, the percent of time the CPU in use? The percent of time the CPU in use. I mean, because what is it called? Because we are giving the Y, right? If the Y is 100, the process will only use the CPU and not spawn any input-output process. So maybe what the CPU utilization be? The percent of time the CPU in use. Because we don't have the input-output, I am assuming 100%. Maybe let's find out. Okay, wait a minute. Let me check this one. Sorry. Run CPU. Okay. This is ready. Then run CPU again. Alright. Interesting. 100C, okay. And then put the P flag, right? This one. We're printing the status. I mean, yeah, this is the one, right? Or statistic, maybe is the word. Print statistic at N, only useful with C flag. Yeah, I mean, only useful because if it didn't provide the C flag, right, the default is false. And the destination is solved, which is this one. So if we didn't provide the C flag, we will exit in this line, the exit 0, and we'll skip this instruction, So that's why we need to provide the C flag. My hypothesis. otherwise stats are not printed, right? Because we are skipping this in here. We already exit from the program. If we didn't provide the, what is it called? The TC flag. Okay. Otherwise, store underscore true. Okay. Action store underscore true. Oh, I am not sure what score underscore true means. Right, it's 100% because we are only using the CPU without input output. Okay, why do you know this? Take a look at the source code, I guess. I mean, because the source code clearly explained that if the probability is 100, then we will only use CPU, no input-output process. But yeah, if we cannot access the source code, why do you know this? But again, maybe it should be okay. It is also pinned in the help menu, right? If y is 100, the process will only use the CPU and issue no input-output. Or well, we can also take a look at the, what is it called? The report, I guess. So maybe to answer this question, why do you know this? The information is from this report of what would happen running the CPU and then running on CPU. So the CPU utilization is 100% in this case. Okay. Now run with this flag for 100. Oh, 1 and then 0. So the second process is only input-output, I assume. Yeah, for CPU process and then 1 input-output, right? Okay. Apa-apa ya? Yes. What is it called in English? It's Wednesday. I kind of forgot. I don't think I can accompany you right now. Oh, no worries. Yeah, I go to church, so that's why a little bit later for the live stream. Good luck for today. Thank you, Ping Bong. Okay. This flags specify one process with 4 instructions. how to use the CPU. How to use the CPU, and one that simply issues an input-output. This flag specifies one process with 4 instructions. One process with 4 instructions, okay. How to use the CPU, and one that simply issue an input-output and waits for it to be done. Write this one. And waits for it to be done. How long does it take to complete boot process? How long does it take to complete boot process? Complete boot process. Okay. Wait a minute. Total time 10. Okay, I didn't realize this previously. Okay. Maybe this is the time that this homework asks. How long does it take to complete boot process? 2010. Okay, I assume this is one time, right? So this is maybe 4 time. I mean, I am not sure what is the time measurement in this. Is it second or millisecond? Yeah, I'm not sure. So I assume this is for time, and this is that's simply an issue for it to be done. So maybe 6 for time in the first process or process 0, and then the 2 times in the process 1. Maybe. Let's find out. Oh, okay. Total time 11. Interesting. Is this always consistent? Okay. So when the input-output run, it has 1, 2, 3, 4, 5. 5, what is it called? Instruction maybe? Oh, maybe from this one, right? This one, the input-output line, the default is 5. How long an input-output takes? So if we change this, right, maybe something like 2, maybe. It's only take 2 times. Okay. So the 5 is from here. Input-output line. Alright. this one. Okay, and then of course we also calculate when the input output done, right? The total time is 11. Okay. Yeah, I cannot forget about this option. Okay. So it was how long does it takes to complete boot process? 11 time. Whatever the time measurement there. So it's the order of the process. This L1, okay. 1, okay. Alright. This is the probability. Okay. What happens now? The switching the order matter. The switching the order matter. Why? Okay. Let me check. Something like this. Okay. Right, we switch the process here. Okay. And then the switching to order matter. I am still not sure. I mean, input output run later. Right. I mean from how long it takes to complete, it should not matter, but I'm not sure. Let's find out. Okay, it matters. Okay, right, input output block. Oh, right. Okay, well, okay, the difference, right? The difference is that how to explain this? First we run this, right? We run this and then the input output process is ready. It means we haven't run this yet. And then when it is done, right, we just run the input output. And that is why it took longer than when we switched the process. You know, while, what is it called? While the input output block, in this case, right? While the input output block, we can use the CPU to run the other process, you know. And when this is done, right, we can go back to the input output process. So this is, what is it called? The total time is shorter because we are switching the context or the process while the other process waiting for something, right? Okay. So does the switching to order matter? Yes. right? Because by switching the order while we wait for the input-output process to finish, we can switch the CPU to another process. This one. Switch the CPU to another process, and then, well, when this is done, we can move back to the input-output process. So switching the order matter because while waiting for the input-output, it is the first process, we can run the other process. Well, in this case, right, we need to finish this first. What is it called? The process that takes CPU first, and then switching to the input-output, which means that the CPU is idle, something like that, when we switch to the second process in this case. Okay, let me check this one, right? So yeah, this is blocked, which means we are not using the CPU, and the CPU in this scenario not doing anything until the input-output finish. Alright. Why? Okay. To explain that, because while waiting for the input-output to finish, we can run another process, which means that the execution of the program can be shorter than this order, running the CPU first and then the input-output. This is my hypothesis, which might be wrong. But we will see. We will now explore some of the other flags. Okay, one important flag is this S. Let's already take a look at this, right? The default is switch on input-output, and the other one is switch on N. I'm still not sure. The policy in here, what kind of requirement switch on N need, and what kind of requirement switch on input-output means. We will see. This determines how the system reacts when a process issue an input-output. With the flag set to switch on N, right, the system will not switch to another process. Switch on N, the system will not switch to another process while one is doing input-output. Oh, okay. So rather than running, what is it called? Running another process while waiting for the input-output, right? We are not switching to another process, which I assume something like this. It's just in reverse. The block state in here and or maybe in here. and the done state is in, or maybe ready state is in here. Now let's find out. I mean, from the, what is it called, report, it's not really obvious yet, right? Can we do something like this? Switch on I/O. Oh, okay. Switch on I/O means that when the input-output block, we switch to another process. Then waiting. Okay. Do we need to use capital keys? Let me try. Alright, let's see. We got an assert. It needs to be, what is it called? Uppercase. Oh. Uppercase. Okay. This one, right? When the current process is finished. Now let's try running this. Right, it become 11 again rather than 7, like this one, because rather than switching to another process, we are waiting until the input-output process finish, or maybe until any process finish, right? System will switch when the current process is finished. If you take a look, the other option, right? Current process is finished or issue an input-output. So in this issue an input-output means that when the current process doing some input-output stuff, we switch to another process. Alright. Okay. Instead waiting until the process is completely finished. Instead waiting until the process is completely okay. With the flag set to switch on N, the system will not switch to another process while one is doing input-output, instead waiting until the process is completely finished. Okay. What happens when you run the following two processes? Okay, we already done that, right? One doing input-output and the other doing CPU work. It kind of becomes the same. Like, let me switch this. Kind of the same like this, right? The difference is that, well, one process already done in, what is it called? If we run the CPU process first and then the input-output process, on this one, the other process is not done yet. It's in the ready state. So there is some slight difference, which means it depends on our intention, I guess, which one we want to do. Now run the same process, okay, but with the switching behavior set to switch to another process whenever one is waiting for input output. Okay, similar to this scenario, right? Switch on IO, okay, it become something like this because it is the default, right? Okay, let's try that out. Switch on IO, okay. Oh, yeah, okay. Right. I kind of forgot about this. Forgot to switch back this one and then comparing these two. And okay. This is switch on IO. It is the default behavior or the default process switch behavior, right? The switch on IO, and then this one switch on N, another option for the process switch behavior. Okay. Another important behavior is what to do when an input-output completes. It is right? This one, input-output done behavior. Input-output run later. Okay, run later. Input-output run later. When an input-output completes, the process that issue it is not necessarily run right away. Oh, so we are not really switching to the input-output process, right? I assume something like that. So we are waiting for another process to done first and then switch back to the input-output one. That make me curious. Like, what happened when we use this? I run it, right? We'll run immediately, okay, and then check this, okay. Still running the CPU, okay. Maybe we can change the IO length. I mean, or well, the IO length so that the IO can finish. What is it called? Can finish quicker than the CPU one. I mean, the CPU process is 4 process, right? This one, and well, the default for input length is 5 time for the IO to take. So okay, let me provide that. this one. What happened when we are exactly 4? Like the same with this CPU process. Let's see. Non-immediate. Okay. It is just so happened that we are done, and then we run the input output, I think. So what happened when the input output time is lower than the CPU process time is 4, right? This is the case where the input-output process or time take as long as the CPU process time. Maybe that's the word. Anyway, it is equal, right? For the CPU time and then for the input-output time. Now we are trying out the scenario less than the input-output, and well, we can also change this, I guess, to 3 rather than 4. But let's try out with this scenario, the input-output length 3. Okay, now we see something different. In this case, right, exactly, what is it called? The input-output finish exactly at the same time as the CPU process finish. So we didn't really see any interesting behavior, right? I mean, this is basically something like this, right? The end of the process. But if we use less than, the time required for the CPU process to finish, so this behavior, input output run immediately, show some difference is in this one. Okay, so we finish the input output, right? But we are still running the CPU process. So with this input output run immediate, the CPU process become ready state, change to the ready state, and then we are finishing the input output process first. And then when this finish, what is it called? We going back to the CPU process. Okay, this make me wonder what would happen if we have 3 processes. Right? The first process is the input output process, the second process is CPU process, and the third process is input output process again. Let's find out. Okay. Okay, run CPU. Done. Okay, maybe we need to, what is it called? increase this to maybe 6, something like this. 6 from the, what is it called? The input output length that we specify rather than the default 5 input output length or time, maybe that's the word. Okay, let's check this out. Okay, right, we are still finishing this one. Okay. Now let's try this out. Okay, right. So what is it called? We run input-output process for the first process and second process, and then the CPU process on the third process. So let's see. Okay, run input output. Okay, then block, right? Then run input output and then block again, and then we run the CPU, and then this one is done. So it become ready, the CPU process, right? Become ready, and the first process is done. Now this one is done, so which means the CPU process is not executing yet. Waiting for this. This one is done, and then we run the CPU until finish. Okay. So maybe in this case, it's not necessarily 3 or 6. Maybe 3 would have been enough, right? Ready, and then just run our we have to finish the CPU run. I'm assuming. Okay. The process that issued, it's not necessarily run right away. Rather, whatever was running at the time keeps running, right? This is, what is it called? This behavior is similar to this one, right? We are not immediately switching back to the input-output process, but we are finishing what already running at the moment. And then with this process finish, we are going back to the previous process, the input-output process. Okay. I'm waiting until the process is completely finished. Okay, I think not that one. Wait, where am I again? Oh, in this one, right? Input-output run later. When an input-output completes, the process that issue it is not necessarily run right away. Rather, whatever was running at the time keeps running. What happens when you run this combination of process? Was running at the time keeps running. This combination of process, okay. Oh, we have 3 input output and then 5 CPU. Oh, not really 5. What is it? 15 CPU process. Switch on I/O, right? So we are switching back to the input output when it is finished. Right. Oh, sorry. This is yeah, I'm kind of confused. Okay. Switch on I/O, which means that when one process doing input output, we are switching to another process. Okay, wait a minute. Oh, input output run later. Okay. And this is the default input output run later. Are system resource being effectively utilized? Let's find out. Switch on I/O, okay. Run letter. Okay, we are still using 5. The default I/O length, right? And then this one is 3. Okay. 500. This is 5. 100. Okay. Alright. Let me check. Switch on. Okay. Put output. Okay. Block. And then running the CPU, right? And then this is done. Okay, running the CPU. And running the CPU again. And then we are going back to here. I don't think this is effective. I mean, again, right? We are waiting for the other CPU process to be done and then going back to the input-output process, which can take a long time, I guess. So I assume to make it more efficient, we can do something like this. We are switching back to the input-output immediately, And then when the input output block, we are switching back to the CPU. Let's find out. Okay, total time 31, right? And now total time is 21. Okay, here's the thing. Right? When the first, what is it called? The first process with its input output was blocked. We run the second process, right? It is the CPU process, and quite, what is it called? Quite coincidentally, right? That's the word. Coincidentally, is 5 process for the CPU. So by the time the CPU process done, this one, the input output also done, and then we can run the another input output again, waiting this to be what is it called? Waiting the input output to finish with this 5 time, whatever measurement it is. And then after that we can run the second process, the CPU process, which is coincidentally also 5 time. So the second process is done. The input output process also done. We are running another input output, and then while waiting for the input output to finish, we run the third process, this one, and then this one is done and input output also done. So maybe this one is more efficient rather than using the input output run later, right? I mean, while waiting for the input output to finish, we can run another process. Okay. Are system resource being effectively utilized? I don't think so, because it is blocking on the input output process, which can take quite a while. That is my hypothesis, at least. Now run the same process but with input output run immediate set, which immediately runs the process that issue the input output. How does this behavior differ? Okay, I think I already explained that. Basically, when we run the input output immediately, right, we can utilize the, what is it called, the system resource effectively, because while waiting for the, what is it called, while waiting for the input output to finish, we can also finish another process. So this is the first input output process. We are finishing the second process, and then we are executing, what is it called? We are executing the second input output process, and then in the meantime we are finishing the third CPU process, and then going back again to input output, right? Where the input output is being, what is it called? Is being blocked, I think, something like that. while we are waiting for the input output to finish, we can finish the fourth process, or PIT3, this one. The PIT3. And then by the time the PIT3 finish running, the CPU process on PIT3 or process IT finish running, we are also done with the third input output. How does this behavior do? That's the answer. We can, what is it called? Switching context more efficiently while waiting for the input output to finish. We can finish another process first. But yeah, I am not sure if this is effective for the process less than or more than 5. Let me check. 5, okay. Alright, let me check. Okay, 24. The time is 24. Right. We haven't finished every process yet, and we are switching to the input output and run the last process. Okay, 24. Let me change this to letter. Okay, looks like using input output run immediate might be faster even when the, what is it called, CPU process took longer than the input output process. Okay, when make running a process that just completed input output can be a good idea. When make running a process that just completed input output can be a good idea, because in the meantime, while waiting those input output to finish, right, the process that use input output again, right, to finish, we can finish another process too. That kind of give an illusion of running two process at once, something like that. Again, I'm calling that an illusion because I'm not really sure if it is really running at the same time or not. Okay, now run with some randomly generated process using the flag test as 1. Okay. We are utilizing the seed flag. The random seed flag. It is well the default is 0, right? So there is no randomization. Is that the word? Maybe. Some randomly generated process using flag S. Test S, okay. Oh, now we are 50-50. Okay. If you can predict how the test will turn out. Okay. Can I predict that? I'm not sure. Okay, first thing first. No, not that one. Okay. 50-50. Now let me try to understand 50-50. Is it like consistent or not? I mean, we have to process, right? Let's do this instead first. We have 4 and then 50. Okay. Input, output, CPU. Okay. Now if we have 3, okay. Oh. Did we prioritize the input-output process with the probability? Maybe, or maybe that is the seed. Okay. Not really. I assume. Okay. Interesting. Oh. Okay. At least it is kind of consistent, maybe. Yeah, so far I assume it is consistent. But yeah, let's check the first case, right? What is the default run letter? Okay, this one. CPU. Yeah, looks like it is what is it called? The process generated kind of consistent. Okay. Alright, so what happened in here? CPU, or maybe PID 0, PID 1, PID 2, okay, and then CPU ready, maybe run CPU ready, and then ready, right? And then done. Run IO ready. Wait, let me check again. Where is it? Run IO, okay. So it is still ready, right? Done. Log. And then run IO. Oh, sorry. We are using the policy IO run letter, right? The default policy. input output run later. So that means this one should be ready, I assume. And then this is, what is it called? 5 time. And then this one is done. Maybe run IO done. And this one is run IO. This one is done. This one become block again. And then run IO done. Maybe something like this. Maybe. Let's find out. Wait, how many is it? Okay, 14. Okay. Oh. All right, we only have to process. Okay. We only have to process, not 3. Anyway, run CPU, right? So maybe I should change this one to this one. Something like this. And then block. Switch on IO. Okay, yeah, I completely misinterpreted. Okay. Let me try again. D0, IT1. Okay, we run the CPU, right? Okay, this one, the CPU, and well, let me check this. CPU, output, okay. Ready, and then input, output, still ready. Clock, okay. And then run CPU, right? Run CPU again. I think this is done. And this haven't done yet. Right? 1, 2, 3, 4, 5. Then run, input, output done. And then run another. This one. 1, 2, 3. Oh, 1, 2, 3, 4, 5. Maybe something like this. Maybe. and then this should be run IO done. Maybe. Okay, let's check 15. Run CPU ready and then run IO. While block we finish the CPU. It is only 3 process, right? We run the IO. Oh, sorry, this one. We run the IO, getting block again. Then we finish the IO. Let's compare. Okay. Run CPU. Okay, run IO. Still ready, right? And then block. Still done. Okay. And then IO done. IO and then block. IO done. Okay. That is the first scenario. Now let's try the second scenario. Alright. Oh, sorry. Let's take this. The report, something like that, right? PID 0, PID 1. Okay, this is process 0, this is process 1. Run input output, ready, right? Block, and then what is it called? Run CPU. Okay, and then block again. This one should be done. Alright. Or maybe we have immediately run IO. I think this should be done. Let's find out net run and then run IO. Okay. This one is blocked again. So both of this was blocked. Is that it? And then running again until this one is 5, right? 5 times. And then run IO done. This one is blocked. Then maybe run IO again. Block, okay. 1, 2, 3, 4. This is the last one. 5. This one become block. This one also block. Then okay. Oh, sorry. And this one become block. Right. This is the last one from the PID 1, right? And then we run IO done, and then after that run the IO again, also block. Okay, let me check. Block. This one is 4. I need another one. Okay. Become 5. Run IO done. Block again. And then okay, we have 4 already on the PIT one, and then this one CPU. Okay, then this one we are running CPU. The first IO on PIT1, and then the second IO on PIT1. Block, okay. This is run IO done, I think. Oh, no. 2, 3, 4, 5. Done. Okay. And IO done. Maybe something like this. Well, let's find out. Okay. Run input output ready. Okay. Block run CPU. Okay. Oh, okay. We didn't print out the done status of the run CPU. Okay. Yeah, that is what I'm not sure. I mean, previously, where is it? Yeah, right. Previously, we print out done. Maybe not this one, but yeah, maybe this one. Print out done. Sorry. Output done. Okay, so if that is the case, then yeah, I think this is not correct. Okay, maybe this should be something like this, and then we start block in here, right? 1, 2, 3, 4, 5. Moving to this again. 1, 2, 3, 4, 5. This one IO done maybe. And then running IO again. Block, okay. This is 5. This one. 1, 2, 3, 4, 5. Okay. Turn CPU 16. Okay, let me compare. Run input output ready. Okay. Block, run CPU, run input output, block. See, run IO done. Right, block again. Run input output. Okay. And then block, and then this one, right? Run input output done. Run again immediately. And then block. Okay. Output done in this one. Okay, wait, let me check. 1, 2, 3, 4, 5. Okay, output done. CPU done. Okay. Yeah, what I am confused previously. Do we print out the done status when running CPU or not? Looks like we are not, and can just run the next process maybe. Okay, that is the second case. Now let's try the third case. Of that. Oh, now this is interesting. I didn't realize that the cursor is different. Okay. Well. Anyway, about this address. Okay. The PID 0, sorry, then PID 1. CPU input output. Okay. Run this, run the CPU process, and then ready, and then do we run this? I think we are running the input output directly. I mean, I'm assuming something like this, and then block. Okay. And then what is it called? Run the input output. Okay. This one is block again. Right. 1. Okay. This is 4. Okay, and then 5. Right, and then this one I think become an input output done, and then we're running CPU. I deblock this 5 times. So is this become ready? I think. Oh, sorry. Okay, no, that's you're running the CPU. Okay, ready. And then this one is done. And then this one run input output again. Clock. Okay. 5 times. And then I'm all done. Then CPU. And then done maybe. I'm not sure if we need this. If we will print out this. Well, let's find out. Okay, we didn't print out the last one. Okay. Okay, let's check. Run CPU ready. Run input output ready. And then block run input output. Okay. Block. Okay. Run input output done. Run CPU and then ready. Oh. Okay, interesting. Run CPU. Okay, so we print out this one. Output done. Okay, that's I missed that. Okay, so something like this, and then this one, right? Block. Okay, done. CPU. All right. Okay. New use flag versus what happened? Oh, there is a lot of possibility in there. Okay. I think I will take a look at this on the next session. It's gonna be a long process, I assume. Right? We check with the first case. I mean, we check with the default one, right? Input output run letter, and then we might compare that to the what is it called? Input output run immediate, right? Comparing these two, and then comparing this one to switch on input output or switch at the end of the process. Okay, let's save this for another session. So that's it for now. Thank you for watching and see you next time. Bye bye.